On.
I, Jayant Kumar Ogde,
And I, Harshit Gupta.
have designed a machine that emulates the human characteristics. So basically, we have designed the wrist portion of the human hand into which we have incorporated the human characteristics. So coming to its phalanges, basically the finger portion, the lowermost portion is known as proximal phalanges, the middle portion is known as middle phalanges, and the upper portion, topmost portion, is known as distal phalanges. So this was all about the phalanges part. Beneath them there lies the metacarpal bone part, which lies from the beneath the phalanges to the carpal bone, to the wrist basically. So this is known as the metacarpal bone part, and as this whole part is acting as the base to the metacarpal and the phalanges, it is acting as a carpal bone which provides that 360-degree rotation to our wrist. So this was all about the human hand characteristic classification. Coming to its working part, we have attached the servo motor beneath each phalanges, to which we have tied the strings which are inserted through the phalanges and are tied to the topmost portion, which is distal phalanges. This mechanism is to provide the flexion operation. Basically, whenever the servo motor rotates at an angle, the finger also undergoes flexion, and the extension undergoes then and there itself, due to the fact that we have used the straws of quite stiff nature. Also, we have used the MDF sheet, which is basically known as medium density fiber board, for its stability. Coming to its back portion, where we have made all the connections, here are the servo motors, the breadboard, the NRF sensor trans receiver, and the microcontroller, which is Arduino. There are three terminals of the servo motor, which are basically VCC, that is main power supply, the ground, and one signal terminal. We have connected these three terminals to the microcontroller via breadboard. Also, we have attached an adapter for the constant power supply to the that is 3.3 volt power supply to the NRF trans receiver. Here the NRF is acting as a receiver which receives the signals from the transmitter transmitted from the variable sensor part. So and for the signal part of the NRF sensor, we have connected it directly to the microcontroller, which is basically Arduino. So this was all about the biomechanics part of the human hand.
So this is the transmitter glove, which contains a flex sensor like this. This sensor is made by us only, and now we are having a mini breadboard, this trans receiver module, and this Arduino board, basically a microcontroller. Now the flex sensor is attached to a mini breadboard, where we have these 100 kilo ohm resistors. The resistors we have used for obtaining a precise output by this sensor, and the output are directly going to the analog input of this microcontroller Arduino. And this coming to this device, this is an adapter for this transceiver module. We have used this adapter because the transceiver module requires a constant 3.3 voltage, which Arduino cannot supply. It cannot supply a constant voltage to this board. So we use this adapter. This directly supplies a 3.3 voltage, and the communication between these two boards are using a very special protocol, which is a SPI protocol. SPI is Serial Peripheral Interface Protocol. And whenever the sensor gives whenever a sensor takes a data or changes the resistance value, basically this flex sensor works on a principle of changing a resistive value. When we bend this sensor, the resistance changes, and we extend this sensor, the value decreases or increases, whatever the algorithm we have set it. Okay, so when I move my finger to this, or I perform a flexion, the value changes and goes in the Arduino, and this Arduino processes the data and transmits it by this transceiver. Basically, this transceiver used as a transmitter in this case, and the transmitted value is received by this another transceiver. In this case, this transceiver is used as a receiver, which receives the data and sends this data to this Arduino, and these are the servo motors which are attached to this Arduino, and they perform a algorithmic output, or we can say the function. When I move this finger, that data is transmitted by this transmitter and received by this receiver, and this finger, when I move this finger, only this finger will perform a flexion. Okay, so now coming towards the demonstration part. As you can see, when I bend these fingers, the robotic hand also shows the same gesture, and this shows that our machine has good biofeedback. So these kind of machines can also be useful for variety of uses in our day-to-day life.
And it also holds great scope in the field of prosthetics, where such prostheses can be designed and developed. Thank you.
Thank you.